Okay, linear inequalities, hopefully reviewed, but we are doing it again, even though we have covered some of this semester already, because 95% of the class missed it on the first test, and I don't know if that was my fault or COVID's fault or what, but we have to know it to move forward. You can pull these notes from an assignment last week and print them yourself, or you can ask me to print them, or you can just take handwritten notes. You don't have to have a pre-printed version to use it. Let's talk about linear inequalities. A linear inequality is similar to a linear equation, however, with the inequality symbol instead of an equal sign. For example, y is greater than or equal to negative 2x plus 9. Determine which points satisfy the inequality. So I can just generally plug each one of these in and check to see if yes it works or no it doesn't work. So this is my x value, and the 4 is my y value. So if I work it out, will it be true? So is 4 greater than or equal to 2 times 7 plus 9? 2 times 7 is 14 plus 9. Whoops, sorry, negative 14. That is a negative 2x here. Negative 14 plus 9 is equal to 5, and is 4 greater than or equal to a negative 5? Because it's negative 5, yes, that works. This one is valid. Okay. Negative 1, 3. So my negative 1 is my y value. Is that greater than or equal to 2 times negative 2, rather, times 3 plus 9? It's negative 6 plus 9, which is positive 3. And negative 1 is not greater than or equal to positive 3. So that one is no, it doesn't work. Okay. Next, 10 and negative 5. So this one I have negative 5 for my y value. Would that be greater than or equal to negative 2 times positive 10 plus 9? That's negative 20 plus 9. So negative 5 is greater than or equal to that. Negative 20 plus 9 is negative 11. This is a true statement. So yes, this one does work. Okay? So this one works, this one works, this one does not. Does anybody have any questions on how or why I did that? Yes. I'm sorry, can you talk just a little louder? Which one, A, B, or C? For B? Very good. Good. Yeah, I did those backwards. You get a point for that. So, let me correct that. And since I'm writing in pen, I will have to improvise here. It would be 3 greater than or equal to negative 2 times negative 1 plus 9. And therefore, we have negative times negative is positive 2 plus 9. So 11 and 3 is not greater than or equal to 11. So even though I use the wrong numbers, it still doesn't work. And we'll say no on that one. Okay? We dodged a bullet there. Had that been a test question, I still could have gotten it correct by doing it absolutely wrong. But Savannah, right? Let me give Savannah her bonus point. On the next test, you get a reminder that you want to use it. Savannah. Good job, Savannah. Okay. Now, any more questions? You guys are good. Real world example. So what would we do here? John sells t-shirts. Plain t-shirts cost $5 and graphic shirts cost $7. In order to match his product costs, he must make at least $1,200. Write an inequality to represent the situation. Okay. So, this is a question I didn't create. I would have made it a little more interesting, but this is what the shirts cost him, and he wants to make $1,200 in sales in order to break even, I guess. So, an inequality to represent that, if we called the P shirts here, plain shirts P, plain shirts P, and the graphic shirts G, we could say that if we want to just collect our money, $5 for every plain shirt, plus $7 for every graphic shirt, has to be greater than or equal to, it says at least, so that's a greater than or equal to $1,200. Okay. If he sells 150 plain shirts and 60 graphic shirts, will it be able to cover the product costs? We just plug those values in. So $5 times 150 plus $7 times 60. Will that be greater than or equal to 1,200? We just do the math. Five times 150 is 750, and 7 times 60 is 420. So is 750 plus 420 greater than or equal to? Not quite, right? So, no. 1170 is not greater than or equal to 1,200. So I'm going to say no. Everybody good? If he sells 90 graphic shirts, what's the minimum number of plain shirts he must sell to break even? So, using our same equation here, we don't know how many plain shirts he needs to sell, but we want the equation to be true that if he sells X of them plus 7 times 90 graphic shirts, that will be greater than or equal to 1200. So mathematically to solve that, I am going to multiply the 7 times 90 and get 630. 7 nines is 63, so add the 0, 730. So if I have 5x plus 730 equals this, I can subtract 730 from both sides. And that leaves me with 5x. The plus and minus 730 cancel out. Greater than or equal to 1200 minus 730 is 470. And then I divide that by the 5 here. 5 on both sides. And x has to be greater than or equal to 94. Okay, so if it equals 94, wait a minute, something's wrong with my math. 570. This should be 570 here. Is it? 12. No, my math's correct, isn't it? 1200 minus. Oh, I wrote down 730 instead of 630 here. Somebody should have caught that for me. That's 630, not 730, which makes this 570, and this number not 91. It's a Monday, guys. I apologize. I'm making mistakes like crazy. 114. I didn't sleep well, and I don't have enough caffeine in me to make up for that. So 1200 minus 570 is in fact 630. So 570 divided by 5 is 114. So he needs to sell at least 114 plain shirts. In a real business model, you would raise the price above the cost, and that may be what was intended here, is instead of saying they cost that much, that's how much he sells them for. So it's just a term for value. The product cost versus the sales price are normally two different words. Not all math people are business people, though. So, graphing linear inequalities in a visual way, showing the ordered pairs that satisfy the inequality. Put the inequality in slope-intercept form. Graph the line. Use a dashed line for less than or greater than symbols, and a solid line for less than or equal to or greater than or equal to. So that number 2 there is very important. Take a look at that under graphing linear inequalities. Make sure that you remember that. A lot of students miss this part and we'll get it wrong. So graphing some here, we want to shade the line above the line for greater than or equal to, and below the line for less than or equal to symbols. So, excuse me, here first, my y-intercept is -1 on this equation. So that's my first point, 0, -1. And I have a slope of 2/3, so up 2 over 3. And 2 over 3 would be my second point. I connect those two. 2 over 3. And like so. It is a less than, so I'm going to shade below. It's not equal to, so I'll have a dashed line, not a solid line. And shading below will look like this. Okay. So any value that's not on the dashed line, because that means it doesn't include those values, but is below in this shaded area, will make the equation true. So for instance, if I took this point here 2, -1, that would make the equation true. Okay? Now let's see what I'm writing there. This point here, 2, -1, would make it true. Next equation, I have here no y-intercept. If there's no y-intercept, what value is that understood to be? Yes, thank you. Very good. So my y-intercept is 0. My slope is -4. -4 means I go down 4, not rise, but drop 4, run 1. So it's going to go slope down to the right. And is it going to be a solid line or a dashed line? Thank you. So solid line, I think that's pretty close. And we are going to shade, since it says greater than, I shade above the line. Now this one's almost vertical, but you can tell which part is above. If you think about it, it would be over here, right? If you're unsure, you can always plug in a value to check. Okay, we know values on the line make it true, but let's say, for instance, I picked a value over here that was 3, 0. Okay? 3, 0, something in where I want to shade. If I go -4 times 3 for my x value, that's -12. Is -12 less than, or I'm sorry, is 0 greater than or equal to -12? It is. So that's true. That is the right side of the line. So you can always check a value if you're unsure. But above, depending on the slope of the line, makes more sense. But you can see above is going this way, below is going this way. Let's skip 3 and 4. Those are standard form. Let's look at 5 and 6. We need to first put it in y-intercept form. I'm going to subtract 9x from both sides and then divide by 12. If I do that, y is greater than or equal to -9 divided by +12 x minus -60 or minus 60 divided by +12. So I can simplify that. I have y is greater than or equal to -3/4x minus 12 divided by 60 is I want to say 5. It is 5. Gosh, I need some caffeine. And my y-intercept is -5. My slope is -3/4, so I go down 3/4. Or you can do the opposite of that, which would be go up 4 but left 5. So I'll connect my points here. It's a solid line because it is greater than or equal to. Solid line. I'm going to shade above because it says greater than. If you're unsure, you can always check. 0, 0 is a great point to check. If I plugged in 0 times x plus 0 times y, that would be equal to 0. Would that be greater than negative 60? Why, yes, it is. So I'm going to shade this side of my line for the equation. Okay? Any value that's in the shaded area or on the line, if it's solid, makes the equation true. Finally, number 6 here. X is less than or equal to negative 4. Where is x equal to negative 4? It's not this way. It's this way. Okay? So we go over to the x value at negative 4, and I'm just going to put a vertical line here. And, whoops, I should have made that dashed, not solid. So let me go back over it with a different color here and make it dashed. Come in.
How's it going, Mr. Ford?
Doing well. How are you, sir?
Doing all right. Just checking to make sure everything's going okay.
We're all spread out. We're good.
All right.
Thanks, sir.
You're very welcome.
Okay, so we have a dash line here. Let me fix that a little better, and I know you guys probably are using pencils, hopefully. I'm only using the markers because I think the color makes it easy for you to see. Not because I suggest that. Okay. Now, which side will I shade? Okay, below the line would be a good answer. Yes. It's perfectly vertical, though. It's hard to tell what's below it. So think if I plugged in 0 as my ordered pair, as my x and y value, would the equation be true? Is 0 less than negative 4? No. So we know we couldn't shade this side, so it has to be the other side. And that is still below, although it's a little harder to follow that that's below here. But it is. Okay? So if you pick a value over here like negative 6 is in fact less than negative 4, so that makes the equation true. You guys try writing the equation for number 7 and doing that on your own. Go ahead and graph it. I'll go over it real quick. I'll give you just a minute. Gosh, this is an old question. Do any of you guys still get charged per text or per message? Almost everyone has unlimited now. When one of my kids was in high school, he sent 4,000 texts one month, and I paid 10 cents a text. And the girl didn't even like it. That's the sad part. $400 bill to a girl that didn't even like it. She was like, leave me alone. Oh, but I think you're so beautiful. Leave me alone. Anyway, so hopefully you guys have figured that out. We want it to be less than or equal to their budget. We don't want to go over budget. That's how budgets work, right? So my inequality here is going to be less than or equal to $30. And since I'm paying 10 cents per text message and 25 cents for a picture message, I'm just going to call the text messages X. And you can use Y and anything else. You could use T and P. But I'm going to use X and Y because we're graphing it over here. And it's just easier for me to think of it that way. So 10 cents X plus 25 cents Y. Now notice I'm using a decimal in front of my cents because I'm not using one in my $30 here. If I wanted to use 10 and 25 as non-decimal numbers, I'd have to make this value here 3,000. I'd have to add the cents on here without decimals as well. So make sure you're using the same values on both sides. Solve the equation. Y-intercept form. I'm going to subtract 10x from both sides and then divide by 0.25. So that would be 0.25y is less than or equal to negative 10 cents x plus $30. Divide both sides by 0.25. And my final equation would look like y is less than or equal to 0.1 over 0.25. You can just do the math and simplify it, but I want to show you tricks with your calculator because you are allowed to use those on the ACT. Seniors are taking them tomorrow. But if you go 0.10 divided by 0.25 and hit math, enter, enter, it will simplify the fraction for you. So 2/5. And that's a negative 2/5 x. And then $30 divided by 25 cents, it's 4 per dollar, right? So 120. To graph that, we're going to say these are our text messages out here. The X value is text. The Y value is the pictures. But my scale has to match my equation. Okay? The scale has to match the equation. So I have 120 here. That's pretty big. I don't have 120 blocks. So I have to make this equal to values that will add up to 120. Be careful of that. We can't start here with 1, 2, 3, 4. We don't have 120 of them. So if I use something like 10 for each one, 10, 20, 30, I think we're okay. 40, 50, 60, 70, 80, 90, 100, 110, 120 is right here. So my y-intercept is 120, right? and my slope is negative 2 over 5. Now, do I want to use 1, 2, 3, 4, 5 out through here? Do we typically send just a few texts, or do we send a lot? I don't know. Probably a lot would be my guess for you guys, and this person too. So I'm going to use the same scale here. Each one is 10, 10, 20, 30, 40, etc. 50, 60, 70, 80, 90, 100, 10, 20, 30, 140. Edge there. My y-intercept is at 120. What would the x-intercept be for this equation? Where would the x be equal to 0? If I graph that equation, let me just plug it in here. And I said parentheses negative 2 divided by 5 and x plus 120 on my calculator. That's not going to be visible for the same reason that it wasn't visible on ours unless we change the scale. So to see it, you could hit zoom, and down on the bottom we have one that's zoom fit 0. Zoom 0, and you can see it's given me both a x-intercept and a y-intercept on my graph. So now I can look at that if I want. We're just moving my cursor. Looks like way over here at about x equal to 10 and y equal to 116. It goes off the screen, but again, that's not x equals 0, is it? We want x equals 0. So if we go down and we hit zoom again, and we do zoom out 3, and then hit enter, you'll probably be able to see where it actually crosses. So where y is equal to about, gosh, it's big numbers still. Let's look at the table. Second graph gives me a table, and we want the y value to be 0. So what is the x value for y is equal to 0? It goes down. Here's the y value in red. Down, 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 down. It's way down through here, right? So it's a big number. There's a faster way to go down. I'm trying to recall how to do it. But anyway, I could just keep going down through here, and eventually I would get to y equals 0. We can solve mathematically. Let's do it mathematically. I think that'll work better. I hit my camera, sorry guys. Didn't mean to give you whiplash. Uh-oh, I just drew on my shirt with a Sharpie. Y less than or equal to negative 2/5 x plus 120. If my y value is going to be 0, what is the x? So I would subtract 120 from both sides, and I get to get rid of the negative 2/5, to make it 1, not get rid of it necessarily, but cancel it out. The multiplicative inverse, I'm going to multiply by negative 5 over 2. You can multiply both sides by 5, then divide by negative 2. I prefer to do it in one step. That gives me just x on this side. I'm multiplying by negative numbers, so that causes my inequality to flip. Okay, the inequality has to flip, and if I multiply 120 negative 120 by negative 5 over 2, I get 300. So x would be less than or equal to 300 or y is 0. So that's going to be off our chart here, even using this scale of 140. So if we go back up here, our y-intercept was 120. We just stick with the negative 2/5 slope. To go down to and over 5, if this first one is 10, I'm going to have to do that twice. So it'd go from 120 down 4 to go over 10. So this point here would be 120 minus 4 would be 116 over 10. Now, we want this 2 to equate to the same scale here. So what I would do is multiply it by some value to make it equal to 10. So negative 2 times what? 5. Would give me that value, right? So if I want the top number to be 10, then the bottom number would have to be 25. So if I want to go down the whole 10, I'm going to go over 25, which would give me this point 25 for the x value and 110 for my y value. Is that on my table? Have to start all over. X equal to 10. On my table we start at 0. At 10, it's going to be 116. Okay? We did that at 10. I said 25. I may have made a mistake here. Let me look again. What was I trying to do? I was trying to go down so the top by 5, the bottom by 5. Maybe 10 over 25, that's true. Was 116 at 25. Yeah, at 25 it went down a full 10 units, which was 110. So at 50 it's going to go down another 10 units. To 100. Right there. It's kind of hard to plot that, but anyway, graph is going to look like this. It's a solid line as it's greater than or equal to, and we're going to shade below the line here because it's less than. Anything down here is going to keep you below $30. Using your graph, give two possible combinations of text and picture messages where she can stay under her budget. You could literally pick any value in the shaded region here or on the line and below to make that true. A couple of examples, we could do 50 text messages and 70 picture messages. And still below, we'd be below. We could do 100 text messages and 70 picture messages and still be below. So any two that are in the shaded area. We'll skip the last problem, move on to systems. Systems just means there's more than one equation. So we're graphing two equations at once. Remember, solid line if it's greater than or equal to or less than or equal to, dashed line if it's greater than or less than. And we want to shade on the side. If it's greater than, we shade above. If it's less than, we shade below. Let's look at a simple one here real quick and see how to graph. I have -1 as my y-intercept for the first equation here. I'll do it in blue. And my slope is -2/3. That means I go down 2, right 3, second point. That one is a solid line. And we're going to shade underneath. So solid, under, or below. This one is solid, and we're going to go above. Wow. Okay. We'll finish this up Wednesday. Tomorrow is going to be a catch-up day because seniors are taking the ACT.